In this video, we will see how to add two polynomials using linked list. So without any further delay, let's get started.
Let's see how we implement the code. First we execute #include stdio.h, then #include stdlib.h. Then we will proceed with step by step. First we define the coefficient power node. First, what is coefficient? Coefficient means the number in front of the variable x. Next, power. Int power means exponent of the variable x. Then next, struct node. Struct node means it is each node stores one term. It means next to the term. Then next, create a node. When the user, let's create a node. Let's create a node. When the user enters a term, for example like 5x square, we take the coefficient as 5 and the power as 2. Then we call create node as 5 and 2. Inside this function, we dynamically allocate memory for a new node using malloc. Set coefficient equals to 5, set power equals to 2, set next equals to null because it's not connected to anything else. Then we return this new node which can be inserted into the polynomial.
Further on, let us see how to insert a term into the polynomial. Firstly, we have to create a new node, and to create a new node with the given coefficient and power, we are using node ptr new node equal to create node of coefficient comma power. This will store the new term which you wanted to insert. And next, let us look into the if condition. Here, if the polynomial is empty or if the new term has higher power than the current term, then new node pointing to next is equals to pointer polynomial. This will set the next pointer of the new node to point to the current first node, and pointer polynomial equal to new node. Here pointer polynomial will point to the new node, making it as the first new node. And next, if this condition fails, we'll move on to the else part. Coming to the else part, node ptr temp is equals to pointer polynomial. Here temporary pointer is pointing to the first node, and we will enter into the while loop, and this while loop will loop until you find the first node whose power is less than or equal to the new term's power. Next, we have to check if term with same power already exists and then add the coefficient. First, if a node with same power already exists, then add the new coefficient to the existing one, and no new node is added in this case. Coming to the else part, new node pointing to next equal to temp of next. Temp pointing to next equal to new node. Here, if no matching power is found, insert the new node between temp and temp pointing to node. This will maintain the descending order of the powers.
Let us explain about function to display a polynomial. Void display node ptr stall polynomial. This line defines a function named display. It takes one argument, a pointer to the structure of type node called polynomial. Then we use while condition. While polynomial is not equal to null, this loop iterates over each node in the linked list. It continues until polynomial is null, meaning the end of the list is reached. Printf %dx power %d polynomial coefficient polynomial power. This print the current term of the polynomial in the format a power b, where polynomial coefficient is the coefficient of b, polynomial power is the exponent of b. Polynomial is equal to polynomial next moves the polynomial pointer to the next node in the list. Then we use if condition. If polynomial is not equal to null, printf plus. After printing one term and moving to the next node, if the next node exists, polynomial is not equal to null, print plus two separate terms. This avoids printing plus after the last term. Ends the while loop. Printf/n. After printing all terms, if prints a new line for clear output formatting.
Now I will explain the add polynomial function from the program step by step. This function takes two polynomial linked list polynomial 1 and polynomial 2 and returns a new linked list representing their sum. We loop through both polynomials as long as both points to null. If only one polynomial points to null, then exits this loop. Otherwise, enter the loop. Within this loop, we consider the three cases on the basis of the highest exponential value. If current term in polynomial 1 has highest power, add it to the result and move to the next term in polynomial 1 only. Else, if polynomial 2 has highest power, add it to the result and move to next term in polynomial 2 only. Otherwise, the next last cases considered both powers are equal. Add the coefficients, insert the sum into the result and move to the next term in both polynomial 1 and polynomial 2 until while loop becomes false. At the last, add remaining terms of polynomial 1 or the polynomial 2 using the while loop, then return the result. Let us look into an example how the two polynomials were going to add. In the addition of two polynomials, it is going to add only the like terms, which means the term containing the same variable and the same exponent. We taken two examples of polynomials as you see on the slide and the representation of the linked list of two polynomials. Here the first term of polynomial 1 and polynomial 2 is 5x power 6 and 8x power 6 respectively, where exponent of polynomial 1 and polynomial 2 are same, so simply add the coefficient of polynomial 1 and polynomial 2. You can view the resultant linked list, then move to the next term in both polynomial 1 and polynomial 2. Next terms are 6x power 4 and 3x power 2, where exponent of polynomial 1 is greater than polynomial 2. So insert coefficient and power of polynomial 1, then point polynomial 1 to next term. The resultant linked list is updated as we see here. The next term is 2x power 3 and 3x power 2 from polynomial 1 and polynomial 2 respectively. As we compare the exponent of polynomial 1 and polynomial 2, polynomial 1 greater than polynomial 2, so insert coefficient and power of polynomial 1 to resultant, then move to the next term in polynomial 1 only. Then we get the resultant list as like this. And as long as polynomial 1 is point to null, so we going to insert the remaining terms of polynomial 2 in the result in descending order of their power or exponent. Then the final resultant linked list will update as you see in this slide. This is how the addition of two polynomial is done.
Let's look into the main function polynomial 1 and polynomial 2 point us to the need create results as pointers to store the sum of polynomial. Declare n coef POWI where n is number of terms, coef and power to store the coefficient and exponent of the each terms respectively. Int asks user to enter number of terms in polynomial 1. Next, using for loop, read the user input of coef and power. First input polynomial prompts the user to enter the number of terms in the first polynomial. Loops n times to read each term of the polynomial. Prompts user to enter coefficient and power for each term. Calls insert terms to insert the terms into the first polynomial linked list. Second input polynomial ask user for number of terms in the second polynomial. Loops n times to read terms of the second polynomial. Uses
insert terms to insert each terms into the second polynomial linked list.
Display polynomials. A comment indicating the next few lines will display the two input polynomials. Printf /n first polynomial prints the label first polynomial followed by a new line for formatting. Display polynomial 1 calls the display function to print the first polynomial which is pointed to by polynomial 1. Printf /n second polynomial prints the label second polynomial followed by a new line for formatting. Display polynomial 2 calls the display function to print the second polynomial pointed to by polynomial 2. Add polynomials. A comment nothing that the next line performs the addition of the two polynomials. Result is equal to add polynomials polynomial 1 polynomial 2. Calls a function add polynomials that takes two polynomials linked list polynomial 1 and polynomial 2. Returns a new linked list that represents the sum of the two polynomials. Then we display result, a comment indicating that the next line will show the result of the addition. Printf sum of polynomials print the label sum of polynomials. Display result, display the resulting polynomial by calling the display function. Return 0 marks the end of the main function. Return 0 tells the operating system that the program has executed successfully. Thank you.
Now I am going to execute the program to add two polynomials. Let us run the code. We can view the output desktop. Let us enter the number of terms in the first polynomial and then enter the coefficient and power of the terms respectively. Further, let us enter the number of terms in the second polynomial and then enter the coefficient and power of their respective terms. It is giving that the first and second polynomial equation in the format and it will display the sum of the polynomials. Thank you.